Chris Moussa. I've been working on flux-accounting, which is the accounting component for all things Flux as a system instance resource manager. Flux-accounting is much younger than the rest of the Flux project. I've been working on it for about the last 5 years, and it's running as the accounting solution, the accounting interface for Flux on systems like El Capitan and Tuolumne. So I'll go into some background about flux-accounting as a whole, why it was created. I'll talk about how user and bank information is stored and administered in Flux, how it does things such as calculate priorities for jobs, enforce limits, and then finally talk about how job usage is calculated and how system utilization is measured and what kind of role it plays into how job priority is scheduled in the future. So first I'll go over a brief history about flux-accounting. So as Flux sort of emerged as the native system resource manager on a lot of these systems, so too arose a need for being able to manage a bunch of different users, all submitting jobs to one Flux instance at the same time. By default, Flux treats all of these jobs that are submitted to the instance on a first come, first served basis, which is fine if you have maybe a handful of users with a lot of resources. But as you can imagine, on a system like El Capitan, Tuolumne, where there are dozens, potentially hundreds of users, groups of users who may or may not be more or less important than the other, working on perhaps more or less interesting work than the other, there becomes a need to be able to manage all of these jobs coming in at the same time, assign different priorities to the work that's coming through, as well as impose and enforce limits to make sure that the system is behaving fairly. Thus, flux-accounting was born, and this is the accounting interface for Flux as a system instance, managing big groups of users, assigning priorities to different levels of work, and allowing an interface to be able to manage and configure these policies for a site. So I'll talk about all of the information that's stored in flux-accounting. It's responsible for storing pretty much everything that you would need relative to user, bank, queue, project information, recent job history, things like that. It uses an in-memory SQLite database to store and manage all of this data. Pretty much all of the information that's stored in the SQLite database is queryable and modifiable, both through a SQLite shell or a Python API or front-end command line interface. And all of the commands to actually interact with this data are prefixed with flux-account, which allows it to fit in pretty seamlessly with the rest of the Flux command suite. All of the users and banks in flux-accounting are structured like a hierarchy. So there is one root bank from which all sub-banks and users descend from. A user, though, could probably belong to, and does in reality, belong to more than one bank and might have different properties in each bank. So this relationship between the user and the bank that they belong to is what's known as an association in flux-accounting. And then you can configure different properties for this association, both when they're first added to the database and later on. Their needs might change, the bank that they belong to, its needs might change, and so we need a way to be able to conveniently change and view this information as time goes on. Projects are kind of an orthogonal way to track usage for different groups of users who belong to different banks. You might imagine a scenario where there are two different banks that are working on the same thing. So instead of having to create a brand new bank, reconfigure a bunch of properties, and then add users from both banks to a new one, you can just create a project and have both groups of users annotate their jobs against this project. So it's pretty equivalent to Slurm's workload characterization key, or WC key, if you're familiar with that. All right, so we'll dive into how job priorities are calculated and how limits are enforced on a Flux system instance. So flux-accounting provides a multi-factor priority plugin, a job tab plugin that Hobbs was talking about a little while ago. This is loaded by the Flux Job Manager, and one of its sole responsibilities is to calculate priorities for a job as they're submitted to the system instance. It considers a number of factors, but the end result is just an integer priority that ranges from 0 to a really big number, over 4 billion, where basically the higher the number, the higher the priority for the job. It will also enforce limits on a system, both at the association level and at the queue level, which I'll dive into more detail in a little bit, but the goal here is to prevent resource hogging or time hogging from either one user or a select group of users. This actual priority calculation is based off a number of different factors. Fair share, which is just the ratio of how many resources you were allocated versus how much you actually consumed. The queue or the bank that you're submitting your job under. This might change depending on how more or less important your bank or your queue that you're running your job is. And then urgency, which is a self-controlled factor where a regular user might be able to decrease the priority of their own job, or if you're a super admin user, you can decrease or increase the priority of your own job. Each of these factors has a customizable weight that more or less determines how important it is in the end result of the priority for a job. So by default, flux-accounting treats fair share as the predominant factor when determining a job's priority, but your site might have different needs. It might consider that the bank that the job is running under or the queue that it's submitted in to be more important than anything else. So you can configure these on the fly or disable them altogether if you don't find it important. This is the actual priority calculation for a job, and you can see that it's just a sum of products. So just the factor itself multiplied by its integer weight. The flux-accounting documentation contains more in-depth examples for how job priorities are calculated if you're interested in taking a closer look. The other role that it plays is enforcing limits on a system. Again, this is to ensure fair behavior on a system that has to be shared by potentially hundreds of users. It enforces limits on two different levels, both at the association level and at the queue level, depending on the type of control that your site is looking to have over its own system. There are two different kinds of limits, hard limits and soft limits. Hard limits will prevent you from submitting a job altogether. So an example of this would be the max active jobs limit, which is just limiting the maximum number of active jobs that you can have across at any given time. So if you hit this limit and you go to try and submit another one, it will be rejected at validation with a message that says, hey, you're at your limit, you have to wait for a currently active one to finish before you can submit another one. Soft limits work a little bit differently. They will accept the job at submission, but they will delay its execution until a currently running one finishes. So an example of this would be the max running jobs limit, which is slightly different from active jobs. But if you go to submit, if you're at this limit and you submit another job, it will accept it at validation, but it will delay its execution until a currently running one finishes, completes, and transitions to the inactive state. And then it will remove the dependency that's held on this job, and then it can proceed to be actually allocated resources by the scheduler and proceed to run. These limits are enforced both at the association level and the queue level, depending on what your site considers important. Maybe you like both or none at all. And then lastly, we'll look at how job usage is calculated and how system utilization is measured and the role that it plays into actually determining job priority in future submissions. So job usage is just also defined as a sum of products between how many nodes were actually allocated for the job and how long it ran for. So an example here would be if you ran a 10 node job for 5 minutes, your total usage for that job would be 50 node minutes. But this usage decreases in importance as time goes on. And the way that it decreases in importance, it is determined by two different configuration parameters that are set when the flux-accounting database is first set up: the priority decay half-life and the priority usage reset period. The priority decay half-life parameter represents just one usage period where jobs are considered. And as time goes on and that usage period gets older and older, a half-life decay is applied to that job and it becomes less and less relevant to an association's actual current utilization of a system, up until its reset period where it's no longer considered at all towards an association's actual usage of a system. This plays a direct role into how fair share is actually calculated for an association. Fair share, like I mentioned before, is just a ratio of how many resources you were actually allocated versus how many you're actually consuming. It ranges from 0 to 1. 0.5 is the perfect balance. You're using as many resources as was allocated to you, but it can creep up more towards 1 if you're underutilized or towards 0 if you're overutilized. This value, like job usage, is dynamic and it will change over time, whether you or other siblings in your bank have more or less usage. So the goal here is to not permanently affect you if you have a bunch of work recently. How it does this is it uses that same structure that I talked about earlier with banks and users, and it structures the entire database like a weighted tree. It treats all of the banks and users as nodes and then assigns a weight to each node in that tree, using how many shares it was actually allocated versus that of its siblings, and looking at its actual usage compared to that of its siblings. In Flux Accounting, we use a weighted tree node class to actually iterate through this fair share, or iterate through this tree and apply fair share on a regular basis. So you might want fair share updated for the entire hierarchy every 30 minutes or every hour, depending on how frequent or how much traffic your system is getting. The end result is a fair share value, which is just that assigned weight that's assigned by the weighted tree node class divided by how many siblings you have. So again, this will continue to fluctuate as you or your siblings have more or less usage on the system over time. And that's pretty much it. So Flux Accounting has kind of evolved in the last couple of years as the central accounting component for Flux as a system instance. It handles things like user, bank, queue, and project management. It helps with fair share scheduling, tracks historical job usage, and will calculate job priorities and enforce limits on a system that sees a bunch of high traffic. So with that, I'll open it up to any questions if there are any.
Hey, how does it handle licensing?
Licensing.
Yeah, so you have software licenses and you need to track across the cluster to make sure that too many are not in use, but maybe the licenses are also removed as licensed servers. Do you have any tie-outs to those?
So that's not a resource currently tracked by Flux Accounting, but that is something that you could potentially track either on your own without the need for accounting by setting custom attributes on Flux jobs. So that could be something to look at, but that's not something that accounting is currently
just a gripe about Slurm. I don't have many of them. Licensing is one of those half-baked things that when you looked at PBS and LSF and others, it's like a first-class citizen. And it's really important for jobs. Even in the labs, I know you have a lot of licensed software, but commercial use of HPC, it's like critical for what we do.
Well, that's a good thought, and that's probably something we should look into. Anything else?
Okay. So just as a former Slurm administrator, I think my wish list has always been like you have your queue command and then -- me to show your queue and then -- y. Like, why is my, when is my job going to start running? Why is it taking long? And what it essentially comes down to is a breakdown of the fair share, weighting scheme. It's like, oh, well, because you ran this large job, and so, that's why you're in this section of the queue. And then Slurm used to have an S-prior command that would kind of break down the fair share weights. But that's what user wants. It's just like a single line explaining why do my jobs submit quickly and now why is it taking so long, right? I think just that would like be a big quality of life thing if that could be done. And I don't think you need like a model. I think that's sort of like you could code that into like a succinct string perhaps.
No, that's a great suggestion. And actually, Flux Accounting does offer some suite of tools to see how the priority for a job is calculated using all of the factors that are currently enabled on your system. So if you have a question about why my job is maybe more or less important than the other, you can see what actually went into the calculation for that integer priority. And that might give you a better understanding of why your job is potentially behind a couple others, or why it's waiting to run.
Okay, and then sort of in practice, so I think we found it sort of more interpretable if we use a lexicographic sort of sorting with the weights. So you have a weight that's considerably higher than some of the other like factors. That this weight is first. Controlling your sort order. Is that pretty common in sites? Because I feel like mixing them makes interpretation difficult.
Are you referencing
The fair share.
the actual weights for each factor
Right.
when they're determining priority?
Yeah.
So those are viewable and configurable within flux accounting, and the actual calculation, the actual weights that are assigned to each factor are applied and displayed when you're looking at the breakdown for how priority is calculated. I don't know if that answers your question, but
Okay. I was just kind of wondering how people play with them in practice.
yeah.
Yeah.
In practice, I don't know how much tinkering there is actually done with priority calculation. All of the weights are configured in a way where flux accounting fair share is the most important, and really that's the predominant factor that's considered when considering job priority. But I don't see why you couldn't continue to experiment with it, other factors, if you found the use case for it.
Yeah. Thanks.